Good afternoon, good morning, good evening, wherever you might be. My name is Peter Buckley. I'm with Cambridge Technology, responsible for sales. And welcome to our webinar about remaining competitive, building AI-first solutions. I'm going to take you through a quick overview of Cambridge Technology before I turn it over to Rajan Lukos, PhD, our chief scientist, data scientist for Cambridge Technology. And he'll take you through the technical presentation. I'll come on later on in the presentation near the end and give you some next steps to think about. If there are any questions, please put them in the question box in the dashboard on the upper right part of your screen, and we'll get to them after the presentation. But once again, thank you for joining us. We hope that this gives you some information about building competitive AI solutions and get you going on your AI first journey. Rajan? Cambridge Technology began in 1999. We've been around for about 20 years. And over the years, we have built a robust full service suite of IT solutions for our customers. We have about 450 employees located globally in India, the US, and Germany. In the US, we have locations in the Atlanta area, which is where I'm based. Also in Charlotte, North Carolina, Louisville, Kentucky, Topeka, Kansas, San Diego, and Rajan is based in the San Francisco Bay Area. As I said, we also have locations in Germany and India. We are partners on a cloud side with Amazon, Oracle, Microsoft, and Tab, as well as some others, and Google Cloud partners. And you can see some of our more notable customers. In terms of certifications that we have that are industry certifications, we are CMMI Service Level 5 appraised. And that speaks to our application development and DevOps practices. ISO 27001:2013, ISO 20000-1 2011, and we're an Amazon Partner Network Advanced Tier Partner. Go ahead, Rajan, to the next slide. In terms of our capabilities, we started an AI practice going on 3 years ago, I believe. We break it down into 4 basic areas, but AI advisory, where we can assist you with building an AI or machine learning roadmap. There are specific AI solutions we can offer, and we even have a service called AI as a Service. And then we also have done some substantial work in machine learning. We have been in cloud services since 2009, early 2010, when we joined Amazon's partner program. We were one of the first partners to join their program and attended the first partner training program in November 2009, then launched our cloud practice in early 2010. We continue to provide services around cloud strategy, transformation, migration, SaaS development, and we provide proactive monitoring and management for cloud-based infrastructure. Our big data services, we engage in data warehouses, data lakes, architecture, design, cluster setup, management, and all the analytics that go along with it. And this ties back into our AI services as well. And then on the application side, which was one of our foundational services, we've been developing applications for our enterprise customers since 1999. We can do end-to-end projects for our customers. We can accelerate projects. We can help with specific skill sets. We can manage and maintain applications. Some we even do at a code level for our customers. And we can migrate and transform. Some of our, that's fine. And mobility, DevOps, go ahead, Rajan. Some of our partners that we've engaged with, again, Amazon, and we're an advanced tier partner. Identity access management, ForgeRock, New Relic for software analytics, application performance monitoring. We're an Oracle Gold partner. We've engaged with IBM Watson on big data and AI, Confluent for data streaming, Apika, Tableau for data visualization, and CA for identity access management and some other services that they provide. We also, and we'll talk about this a little bit further, in terms of our Amazon capability, we have competencies in data and analytics, Oracle, DevOps, and we're a managed services partner, part of the managed services partner program. We'll talk about that probably a little bit more as we go on. But at this point in time, I'd like to turn this over to Rajan Lukos, again, our chief data scientist, who's based in the California area. And Rajan will take you through his agenda and where he wants to take you on his road and beginning your AI journey. Rajan, it's all yours.
Thank you, Peter. Thank you for joining, and I'll just give a quick overview of how I'll try to organize this presentation going forward. So I wanted to first begin with just talking a little bit about the state of AI and machine learning today. And there's a lot of hype around it, but there's also a lot of substance. And a lot of the work that we do is we actually practice machine learning out in the field with our customers, and we also do some work internally, which I'll describe as well, is separating, kind of the hype from the reality. But I wanted to give sort of a high level about, some important facts that I think really point to the opportunities that are in front of large corporations as well as smaller enterprises, really everybody. I'll talk then at sort of a high level about, and try to be as broad as possible in talking about examples of how AI is driving real business value in some general areas, and I'll throw in some examples wherever I can to try to help get the juices flowing for you as you think about how to get started in this. And then we'll go through about some of the challenges that we've learned in our practice for building AI and ML applications for your business, some of our recommendations for how to get started. And those recommendations will really be about trying to find low-hanging fruit and things like that, but I'll also try to spend a little bit of time. It gets a bit technical. If we have time, we'll spend more or perhaps less on talking about some of the ways in which more sophisticated modeling can actually benefit. I'll go through kind of an extended example there if we have time. And then I'll also kind of wrap up more with talking about, just to give you a flavor about some of the real AI solutions that we have developed, so that you get a feel for what kinds of things we actually work on and we've actually been successful with in how we've deployed AI internally and for our customers. And then finally, in terms of next steps and so on, talking about the data considerations. Without data, there is no machine learning and AI, and how working with Amazon and their platform, really their entire stack of the platform, from storage and compute, that's elastic and variable, to the very specific and powerful AI and ML services that they've put out on API as APIs, and the technology, the platform that they have really for helping you manage your workflow. We'll get into some of that. So I think, just at a very 30,000 foot level, I think this is I always find this to be a really remarkable kind of chart. It's a little bit outdated. It goes up to 2016, but it's just looking at as recently as 2011. The biggest companies in the world were really these companies that you would sort of expect: Exxon, PetroChina, Shell. These companies that really deal in physical commodities, and these are the largest companies in the world. And now, as recently as 2016, you see that most of the largest companies by market capitalization are really data and machine learning companies. I mean, these are companies whose lifeblood is handling data. I mean, Apple's a little bit of they do a little bit of both, but certainly Google is Alphabet, Microsoft in their cloud, Amazon in their cloud, and all of the stuff that Amazon is doing with data, and Facebook. I mean, if you just look at, leaving Amazon aside, looking at Google and Facebook, they're fundamentally digital advertising companies, which deal solely with data and machine learning and AI systems. They have very few employees, relatively speaking. And I think the 2019 number is $1.4 trillion in market value. So the lesson here is that in the span of maybe 10, 15 years, the most powerful and the largest companies of the world are no longer physical oil companies, but they're data companies. And what does that portend for all sorts of other companies in the future? People like to say these days that data is the new oil, and I think plots like this sort of make that real. So I think that what people have learned and what we're coming to believe is that artificial intelligence is really quickly becoming a fundamental building block of business operations, providing real gains in better processes, better efficiency, accelerated innovation. A lot of this has happened because you have advances in machine learning technology and algorithms. That's definitely important. But also the world is awash in data now. And not only that, but you can manage this data and deal with this data using elastic storage and compute in a way that does not require large upfront investment. And I think that's just a huge thing that makes, many companies and who want to enter and start to do their first machine learning projects, it makes it economically viable, right? The fact that dealing with data, running machine learning algorithms, storing it, getting as much compute as you need is now an operational expenditure and not a capital expenditure. And that's so it's really I think part of the thing that's made this revolution is really the commoditization of the algorithms themselves, but just as importantly, if not more importantly, the commoditization and operation and the variable way in which you can get access to compute and storage, just by sitting at your desk. Certainly, in 2019, many surveys show that 40% of digital transformation initiatives will be supported by AI. AI is now, a fundamental building block, and 42% of AI executives say that AI will drive innovation in their organization. So in this part of the presentation, I really just want to kind of take a bunch of broad areas and just try to get the juices flowing in terms of trying to help you and think about ways in which you could use AI and machine learning in your businesses by talking about the ways that others do it. So machine learning in mature AI enterprises, they already use machine learning pervasively. It's a big part of how they think about everything that they do with data, and certainly we've tried to instill that within our organization. Specifically. They inform things like the product roadmaps through intelligence extracted from customer feedback. I mean, one of the people that we talk to is Coca-Cola in Atlanta, and they have these machines that have these flavors, allow consumers to design a drink with different flavors. I don't know if you've seen those, and they use and analyze that data in order to figure out which new flavors they might create new products out of. I don't know if you watched March Madness at all, but I saw, at least when I was watching it streaming, there were all these commercials for a new orange vanilla Coke flavor. Now, I have no interest in that, but I'm sure that that was a data-driven decision, and I haven't tasted it yet. Maybe it's good, but I would bet a lot of money to say that that was a data-driven solution, a data-driven product that was that they took a good a good strong look at. When you think about things like sentiment, today you have access to what people are saying about your company and your business on social media, Twitter, Facebook, but also the ability to do automated analysis using text to speech on calls into call centers, looking at logs of interactions between customer support agents and your customers, and being able to roll all of that up using machine learning and AI into some kind of real-time indication of how customers how happy your customers are. I mean, that's something that CEOs have today that they would have been impossible a long time as recently as 5-10 years ago. And not only just the insight on sentiment, but the ability to kind of cluster and decompose all of that insight into the specific things that are causing problems for certain segments and certain customers. And it's really a revolution in the way that enterprises are really able to understand how their customer base is experiencing their product. We've done some work in our own DevOps and QA through automation and intelligence. For example, we have a cloud operations center, which gets all sorts, is tied into various cloud infrastructures, Amazon cloud infrastructures, and we get we have a team of engineers support engineers who get all sorts of alerts, and we've done a lot of work on using machine learning and AI to make that more intelligent, so that we're looking at anomaly detection, not just reacting to alerts. We're able to make predictions about things that are of value. Let's suppose we have an application that we're supporting that's critical for one of our customers. We have machine learning models that actually give a real-time probability estimate of when that application is going to go down and or fail, and that allows us to be far more proactive rather than reactive to all the things that are happening in the infrastructure. And the next step that we'll take with that is that try to actually make that sort of self-healing. So when we're in a situation where let's say an application that it's our responsibility to keep up, is for whatever reason is starting to have a greater likelihood of actually going down or having some kind of performance impact. We want that to be able to our system to actually, our AI ops system to actually suggest things that we can do proactively to prevent that, and in some cases actually do them automatically. And certainly companies are infusing machine learning capabilities directly into new products, that benefit the end user. It's sort of an amazing thing when you go into Google Photos, if you use that and just search for, photos of tables or lakes or mountains or chairs or people, and you find them. And certainly I think we're all aware of recommendation systems on things like Netflix and Amazon and so on, and those are widely deployed. AI drives research and discovery. So many times you have scientists and materials researchers, let's say, that work on developing new materials, or we work with a large customer that formulates food for pets. And the scientists have a lot of expertise, years and years of experience dealing with these kinds of large spaces of possibilities. There's a combinatorial, large combinatorial space of possible materials or possible formulations for food and flavor and so on. But what we found is that these scientists, and others have found this as well, that nobody can do it all. And the hybrid notion of using machine learning on long troves of historical data about experiments that have been done in the past, and surfacing recommendations for new formulations actually produce novel things that scientists by themselves are unable to do. And that's really an exciting area of research, and something that we have a project working on, and that we're really excited about continuing with. And of course, in industries such as healthcare and life sciences, machine learning models can make predictions that drive towards research breakthrough and new improved patient treatments. I mean, in this area, there's been a lot of progress made, especially as it relates to images. So radiological images or images of skin cancer, for example. I mean, Google has published double-blind controlled studies that actually show that the machine learning algorithms that rely on the latest advances in computer vision are able to diagnose skin cancer better than, as good or better than professional doctors. And I think soon enough, if not already, some of those will be in the market. And that's going to be something that changes healthcare. And I think there's a lot more to do, obviously, in healthcare and life sciences, but we're really already starting to see some remarkable things coming out. In terms of the customer experience, we know a lot about, as sort of mentioned earlier, many of us now have customer experiences that are, highly defined by automatic personalization. We worked with a customer, a large financial service provider that has customers that log into their portal and deal with that bank. And it turns out that even very simple things that use machine learning can make a really, really big difference. So for example, many customers that log into this banking portal, they always do the same few things, right? But everybody does different things. And so if you're using simple machine learning models that sort of suggest the most likely things for someone to do, and that change in time as those people change their behavior in time, and you can then also start to recommend other financial products and so on. So it's not the recommendation systems and these kinds of things that are based on machine learning can significantly drive engagement with customers in all sorts of industries. It's not just the Netflixes or the Amazon Primes or whatever of the world, in really almost any business. And research indicates that 80% of consumers are more likely to make a purchase when brands offer personalized experiences. So really, machine learning models can understand customer behavior and preferences, and recommendations engines are now quite a common way to predict best matches. Another example I think is quite interesting is, we have, for example, this is something that Amazon has worked with Domino's, but I think it's a good example. I have the Domino's app for pizza, and it has quite an intelligent way, I've realized, of sending notifications to me, push notifications to me, that are contextually relevant. It seems it's gotten more intelligent over time. So I think we'll start to see a lot more of this, where people are starting to use machine learning and deep reinforcement learning, in fact, to change and optimize the way that you get these messages, so that you're getting them at the right time, in the right place, in the right context, and the message says the right thing. And I think that's an interesting area that we'll see a lot more of, because certainly we get too many notifications, and there's lots of opportunity for machine learning and AI to improve those. In terms of customer service, conversational agents have been deployed that can dramatically increase efficiency to provide quick responses when possible. I think there's been some hype around these conversational agents as well, but when deployed in the right context, these things can work and improve the customer experience and make it more efficient. Text-to-speech and natural language processing, can be applied to the streams of incoming customer data, such as text, voice messages, and customer service logs, to better understand customer needs and sentiment in order to help improve the quality of customer service. I mean, this is something that I think what we're seeing now is a lot of the technologies that were very successful in, let's say, making Google better as a search engine are now, I think it's been taken a lot more time than I would have thought, are now being deployed at scale in enterprises to improve the ways in which customer service is done. Think about how many times, let's say, AT&T is my internet provider. I have some problem with my Wi-Fi. I go to the website, and the experience historically has been quite bad, but it's actually crazy to think that so many questions haven't been asked before. The technology just hasn't really been there at a sophisticated level to be able to surface automatically the kinds of similar interactions that have happened before and make suggestions and provide answers proactively. And I think we're starting to see that those consumer grade applications of machine learning and AI and text and question answering and processing actually now penetrate into enterprises, and that's going to make a big difference over time. Because any changes to, any improvements in customer service, making it more efficient, making customers happy, that drops straight to the bottom line. In terms of increasing efficiency and productivity, there's a lot of BPO processes, for example, business processes, that have been sort of done by people. And there's a lot of work, and we've done some of this work on using computer vision techniques and some of Amazon's APIs to do data extraction and text extraction from documents that in some cases can dramatically reduce the need for human intervention in any of these things, and can really make more efficient a lot of BPO processes. You can also do things like, we've done some work with a customer who has many IoT devices and HVACs, in fact, these thermal, these things that heat and cool buildings all over the country. And those things are all connected to the internet. And obviously, you're able to get this real-time information on, what is the status of these very expensive machines. Now, we're able to use machine learning to be predictive and proactive about when these things are going to break down. And so you can imagine that if you can reduce downtime for these expensive machines that really affect their businesses when they go down, and being proactive, even if you're not fully accurate, having those kinds of warning signals can really change the economics of those kinds of businesses. And even in other kinds of processes within companies, HR departments are, turning to machine learning to assess job applicants more efficiently. I think there are a lot of pitfalls there, but at the same time, when you deal with hiring, and there's a lot of automatic data extraction and categorization and classification that can happen, and there are a lot of companies, and we work with a startup in that area, of evaluating talent using machine learning that can be brought to bear to processes like that as well. In terms of security and compliance, there's a lot of examples of fraud detection where machine learning, there's so much data, and there's a few, it's a needle in the haystack type problem. There are a few examples of the fraud that happens, and training machine learning models specifically to handle those kinds of things for security, intrusion detection, credit card fraud. All those kinds of things are very, very active areas of work that companies can use machine learning to make huge differences. We have people that we work with in India. If you think about a country like India, there's 1.2 billion people in India, with only 100 or 200 million people who actually have what we would call a FICO score in the US. But it's a growing economy, and one of the major things in growing economies is how do you supply credit, because credit is sort of the lubricant for economic growth. And so there's a huge opportunity there in India to use alternative data and machine learning to help build credit scores for hundreds and hundreds of millions of people who otherwise wouldn't even have access to credit. And that's a very interesting and sort of profound, actually, I think, application of machine learning that a lot of people are working on, and we do some work there as well. Another kind of interesting example that we've come across is companies that have large companies. We work with many large enterprises, very large enterprises that have lots of contracts with lots of different parties. Now these contracts, they may, they're expressed as Word documents or whatever. And there is technology out there that can enable you to use natural language processing to figure out when certain terms of the contract are coming into play, or even when a contract is about to expire. Can all of these things be automatically extracted and made more intelligent so that the people managing it can do it more efficiently and can be more protected from a compliance perspective? Those are some interesting applications. I won't spend too much on this because some of this is sort of obvious, forecasting demand for various kinds of supply chains. I mean, it's an interesting question where companies like Uber and Lyft, are trying to position their drivers or even how to price it so that supply meets demand. There's so many applications for that, where you're able to use data on historical and competitor pricing, weather patterns. All of these things sort of come down into making these key decisions. And it's an example, I think, of where machine learning, where you kind of throwing in as much data as you can and allowing the algorithms to try to figure out what matters for the predictions that have real business value. There's a lot of work going on there. So now I'll just shift gears a little bit and talk about, the challenges that what it really takes to get going, to building your first AI applications. And, as I hope I've tried to convince you, or been convincing in explaining that, it's something that's really relevant for retaining your competitive advantage, because so many companies really are starting to see the value, and it's only going to get more and more important to the way that business is run. So we've described lots of examples, but once a business objective is identified, it's assembling the data that is often the first and most important step. And I think we found in multiple of our engagements, even in our own internal engagements, that organizing and rationalizing the data, not just for the sake of organizing and rationalizing the data, but thinking about it with some machine learning applications in mind, is a very good idea, because that leads to some good, flexible, scalable designs that allow you to build a whole layer and stack of machine learning applications on top of these data stores and around these data stores. And that when you think about it that way, that's really a force multiplier for the value of the data. So it really is important, I think, to try to surface as many potential ideas for what to do. And that's kind of what I'm trying to do in this presentation, suggest as many ideas as I can. Other key issues that we've encountered as we do machine learning projects internally and externally, and I'll just throw out some of these things that actually don't show up when you're first doing your proof of concept, but start to show up when you start to move things into production and deployment. So when you're doing machine learning, reproducibility is an important thing. Like, let's suppose I'm running a credit risk scoring model, and all of a sudden I've got new data, the model is retrained, and I'm deploying the model, a new version of the model, and it's behaving strangely. Well, how am I gonna know that when I was doing my R&D on the model that my production is actually gonna do the right thing? I need to have that kind of reproducibility. And to do that, I need to be able to properly version possibly very large data stores and connect them to the model that they were used to train. And even just model versioning and keeping track of all of these things especially as you deploy them iteratively and rapidly, it becomes a non-trivial thing. And we've learned a lot about how to do that and what some of the best practices are. And I think another very, very important point that's becoming more and more important over time, as you see machine learning and AI models deployed all over the place, is explaining why a model says what it says. So, there are models out there that are used in the criminal justice system to actually do sentencing recommendations, believe it or not. And there's been a lot of work on, kind of talking about the biases and being able to say, well, why is a model saying that this person should get this jail sentence and not another? Obviously, that's a very consequential example. There are far less, examples where real business leaders are given a machine learning model that tells them to behave in a certain way, a way that's different than what their intuition tells them, and they want to understand why. And so a lot of these machine learning models are really kind of, initially they're black box models. And, I spend a lot of time keeping track of, all the research that's happening every day on how to make machine learning models more explainable, being able to talk about why they're saying what they're saying. And that's another key thing that I think you'll find as you deploy models, people will ask you for, and it's important to have answers to that. Excuse me. Assembling the skills can be a challenge. But I think you've seen platforms like AWS and OpEx versus CapEx cloud infrastructure is an enormously powerful democratizing force. And if you can find a partner who has good experience and a good understanding of best practices, a lot of these issues can be made easier by using a principal platform approach, especially the issues that I talked about earlier about data versioning, model versioning, reproducibility. Things like Amazon SageMaker platform is really designed to help you with a nice machine learning workflow where you have a nice loop between you're training your models, retraining your models, and deploying them to production with kind of an audit trail and versioning and reproducibility. And I think that the skills challenge is a far lower challenge than it used to be, as recently as a year or two ago, because you've got some of these great platforms from Amazon, for example, like SageMaker, available for your use. And it's important to understand, the capabilities of those platforms and why, even in your kind of initial phases, it may not seem that important, but down the road when you're actually deploying, and we've seen this in our own experience, they become really important. In terms of getting started then, so what's the best way to get started? And this is really not too much more than just common sense, but I think it's a tried and true kind of formula that we've seen over and over. I would say that one important point to recognize about data science and machine learning projects is that they actually are fundamentally different in a way from traditional IT projects. The way I think about this is, if you're doing some kind of, let's say, database migration from something on-site to the cloud, of course there's risk involved in that. There's project risk, there's budget risk, there's various kinds of operational risk. But there's not a fundamental uncertainty or a fundamental technical risk that says, maybe this just isn't possible. It is possible. It's always possible to do those kinds of things. But in some of these machine learning projects, there is a risk. Maybe you're adding alternative data sources and you're trying to come up with a better credit risk model, and it just isn't a better credit risk model. And those things can happen. And that's not something to fear, but it is something to understand and to know going in. And I think the way to really mitigate that kind of risk is to be very clear about what the business value and the metrics are and what constitutes success. And so that everybody in the organization understands that that's the criterion, and that there is some risk in whether it's going to be possible, but the upside is worth that risk. And I just think it's important to understand that, especially if you're the kinds of people that you're working with are more people who are more familiar with how the kinds of risks that are available to IT projects. I think we would say that getting started is really about three things. It's about trying to identify those low risk but high value projects with clear measurable business benefit. I mean, really, when you're able to do that, that's the key. And they exist. There are things out there that are relatively low risk, even relatively easy to do, but if you're asking the right question of the business, then they can be high value, and that has a lot of leverage. I often feel that as the technology of modeling and so on becomes actually more commoditized, that the real value of working with data and machine learning is not so much knowing everything there is to know about all the model variations and so on, but it's really about learning how to ask the right questions of businesses and start to be able to really ask the right questions about what kinds of questions can we ask of this data that are doable with machine learning and AI. But if you can get those things going, building confidence in the organization is huge, and developing a customer, even if it's a culture within your organization, even if it's in a narrow pocket of success. I think another key thing that we found in multiple engagements is that if you want to choose your initial problems for which the version 0, the V0 is valuable, but that there is a path to many more high-value iterations. So given a choice between two projects that, let's say, both are relatively low risk and can provide value, you really want to be thinking about which of those projects is going to lead you to a whole number of other things that you can iterate to in a continuous path of continuous improvement. I think that that's a good perspective to have when you're thinking about getting started. And now I think I'll spend perhaps a little bit of time, where I don't want to take too long here as we're starting to run short, talking about the ways in which, sometimes the things that you hear about how you can use machine learning are relatively simple and they are high value, but sometimes things get a little bit more complicated. You build a lasting competitive advantage over time by having more data and more labeled training data, but also by building more sophisticated models. And sometimes I'm going to talk here a little bit extensively about a churn model example, where perhaps the simplest thing that can be done with machine learning isn't actually the best thing. Just to give you a sense of where having a more of situations where having a more sophisticated perspective can actually change the way that you do projects and add value to the business. So just a quick overview of churn models. There, let's suppose you have a customer like a telco customer or someone on a prepaid self-plan or something. You have information about them encoded by, let's say, some variable X called a feature, the number of overages they did, the number of marketing interactions, customer support interactions, their usage, and so on. And there's websites out there where people have actually put out data sets on this. Kaggle is a very interesting website that does competitions for data science. And you're trying to predict why the probability the customer will churn within some time period, basically leave your business. And so churn prediction induces a ranking in customers, and it's relatively easy to throw an algorithm out there and get a measure of which customers are quote unquote at risk for churning. But it turns out that that's actually not necessarily the answer, because it turns out, or necessarily the full answer, because you may say, I've decided, let's say, these top 10% people are very likely to churn, so I should send them perhaps some kind of marketing intervention, some kind of maybe a coupon or something that might keep them from churning. But it turns out that people's responses to various interventions actually is highly personalized itself. And so what you see in the plot here is, let's say if you look at point A, that's a customer who has a high probability of churning, which is measured on the x-axis. But when you do an intervention, what does that do to their probability of churning? For some people who are likely to churn anyway, sometimes interventions actually make them more likely to churn, not less, right? And so there's a whole nother layer to this, where once you've identified at-risk customers, that doesn't tell you actually what decision you should make. And so making this distinction between simple predictions based on machine learning and the actual business decisions that you need to make, which is about whether to intervene with a marketing intervention or not. And there's a whole sophisticated methodology for doing this, which is it's a lot like doing drug trials, where you're doing randomized controlled trials of treatment effects, of whether the treatment, in this case sending a marketing intervention, is actually changing behavior or not. And it turns out that there are real examples out there where this kind of thing can make a huge difference in whether the interventions you're actually making, once you have this sort of simple churn model, is the right thing for your business. And it can mean the difference between having a positive and negative ROI on doing marketing interventions for high churn customers. I'll just throw in one example here. This is a real example from a prepaid cell provider. And if you look in the top middle chart, the lower left chart actually, if you think about data volume that a customer used last week, if they're low data volume last week, they are quite risky in the sense that they're more likely to churn. However, it turned out empirically that if you send marketing interventions to those people who have low levels of data last week, they're actually more likely to churn. So it's just a real example that makes concrete kind of the abstract point I'm trying to make. And I just wanted to point out that when you look out there and you see providers who are saying, oh well, we can just provide you prediction models, sometimes you need to think more deeply about the business, and using machine learning is sometimes a more nuanced thing. So I just wanted to run through now quickly a few examples of projects that we have done just to give you a flavor of real things that we've done. I mean, I've mentioned some of them already, but I'll just run through them real quickly. Again, this is sort of intended to get the juices flowing for people. We've deployed a cloud machine learning service on AWS using their workflow with a custom-built algorithm to optimize lead generation for a company that we've worked with for a long time. And it increased their customers' gross revenue by 25% in 9 months. So that was a really great success for us. And I think one of the interesting things about that project was we actually built the data warehouse for the customer. And so we fully understood their data, and it was all on Amazon already. And it was when we started thinking about what could be done with that data, and we actually went and proposed to them how what we thought could be done with their data. We actually gave them 2 choices about how we could engage with them from an AI perspective. One was to have sort of a fixed fee consulting engagement, we would build models and deliver them to them, or the other was that we would actually run a web service that was optimizing their lead generation, and we negotiated a revenue share. So any increase in profits that came from our algorithm versus the algorithm that they had sort of had on by default was something that we participated in, and that kind of works for both because there's no upfront cost for them. They only pay us if we are adding a benefit. So that was an interesting example of AI as a service that was quite successful. I alluded to this earlier. We deployed AI within our own cloud operations center to dramatically reduce the time and labor costs of classifying and triaging the flood of alerts that come from application monitoring. And it allows us to be predictive instead of reactive. I also mentioned a little bit, we developed an AI algorithm for an R&D organization that performs extensive experiments every day using live animal subjects. So we developed so we also built their data warehouse, and because of that, which had data going back about 10 years, we were able to use that data and actually propose on our own, because we understand the data, an interesting algorithm that could actually predict every day what happens with experiments that they were doing. And it allows them to, it can allow them to filter out the experiments that are very, very unlikely to succeed, and that they're really wasting animal and scientist resources and operational resources in running. That was a very interesting example of where we're able to use AI and machine learning for real business value, and our insight in having sort of built the data warehouse was a key thing there. A lot of times it's about asking the right question. I think that's an example of that. We've done some work on using satellite images. I mean, today it costs about $100,000 only to send a satellite into orbit and send back satellite images. This is a huge kind of revolution in the remote sensing world. We've developed a computer vision AI algorithm that uses satellite images to automatically detect new construction in certain suburban areas, and we work with a company that supplies building materials and construction, various kinds of materials and products that are relevant for early new construction. And so this is a lead generation tool for them, where we have algorithms that automatically suggest places where this is in a developing country actually, where their on the ground sales team can go, and we've done very successful field tests that actually show that it works extremely well. In the agriculture space, we've developed we've deployed deep learning based algorithm on satellite images to predict corn and soy crop yields in the US and South America. The way that works in the US is that about 5 times a year, starting in August, the USDA sends people out to do surveys and measure crop yields, do sampling to measure crop yields for corn, soy, and others. And then they release those numbers about 5 times a year until the growing season is done in January the following year. And those numbers are actually financial market moving numbers. And we've developed an algorithm that uses satellite images that can basically produce a real-time forecast of crop yield. And we've demonstrated that it's as good, and in some cases better, than the USDA's numbers themselves. So that was a really interesting example of the way that it was a great example of how all of this stuff ties together, because these satellite images are actually government satellite images that you can get for free, but they're so large that in the past you would have had to ask for DVDs or hard drives to be sent with you. Now these things are actually hosted native on S3 and Amazon, and you have the infrastructure to be able to process these images on demand. You don't have to have your own data center to do it. The algorithms exist out there, and we've proven that, and others have done similar kinds of things that really show that there's a lot of value to be uncovered from these kinds of satellite images if you have the right technologies. No human can look at these things, and they're as competitive with humans on the ground, and in some cases better. And we've developed a number of novel recommendation systems for food delivery startups and a clothing wholesaler. We've developed some reinforcement learning AI approaches to manage IoT environmental sensors and controls, increasing energy efficiency. I sort of already talked about that one, about the HVACs and the temperature control. We've used computer vision to automate a previous BPO data extraction processing, basically pulling information out of thousands and thousands of electricity bills, things like that. And we've developed an AI platform for predictive models for the shipping industry. We have a customer that maintains a fleet of ships, cargo ships, and they want to understand that that's a business with high fixed costs, and so they really want to have some predictive analytics to understand when their ships need maintenance, the efficiency of their ships, and things like that. That's kind of something that we're just getting started working on, and I think it's quite an interesting problem that may generalize into a number of interesting things. So now, just to bring this full circle back to AWS and what AWS can do, AWS has all of these amazing application services that are very specifically about, face recognition as a service, speech synthesis as a service, natural language translation as a service, chatbots as a service, and all these things that are very narrow and vertical, and those are extremely useful for people who want to get started using those kinds of technologies. The platform services, where you're able to deploy machine learning models, on all of this infrastructure, that's just amazing. And I think even more importantly to that, I alluded to this earlier when I was talking about SageMaker. I think they can really help you with things like SageMaker that have some, that really help you, really guide you into having good, efficient workflows as you're deploying and versioning models. This is just more sort of specific about some of the AI services. So recognition is the image recognition. There's work on video, text extraction, poly and transcribe, translate. All of these things are working and available, and we've used some of them quite successfully. The ML services like SageMaker allow you to build, train, and deploy in a sensible way using best practices that are kind of defined for you. And then there's lots of different ML frameworks and infrastructure that we can, help you understand greengrass for IoT and things like that. So there's really a wealth of resources that allow people who want to get into it quickly and at relatively low cost. So now I'll hand it back to Peter for next steps.
Thanks, Rajan. Just a few more minutes, folks. Just kind of give you some things to think about in terms of beginning your AI journey, and some points to go over very quickly for you. But take a look at automation, how to optimizing your existing processes. I know that Rajan talked a bit about some of the automation that we've introduced into some of our customers' environments. It helps you to maintain and or improve your quality and reduce cost. You move on to enrichment, where you get to add new features to products and services, and you increase the engagement and attract new customers. All of this through your AI journey. And then invention, it helps you create new projects and categories, and it helps you leverage your industry experience and your AI expertise, and ours if we can help. Next slide. Then finally, you need to create the loop, connect the technology initiatives with the business outcomes. It's continual feedback into your processes to make sure that you're continually learning as well. Then advance your data strategy, assess your structured and unstructured data sources. Rajan talked a bit also about data lakes and data warehouses and what they provide for you in terms of the different data sets that you might be trying to work with. And then get your machine learning in the hands of your developers so you can organize for success. They're just some points that you can look at in terms of beginning your AI journey. And then the last thing that I'd like to go over is that, as I said earlier, we're an advanced tier partner with Cambridge Technology. We have competencies in big data, DevOps, managed services, and Oracle. And Amazon and Cambridge Technology, we jointly make funding available for customers to run POCs and more projects, depending on the use case. If you have a project in mind or you're thinking about something, leverage our relationship with Amazon, and we can kind of get you going quicker and at a lower cost, if at all possible. We'd love to have a conversation with you to show you how we can bring all the resources we have to bear on your AI and machine learning project. My contact information is there. As I said, we take a look, but I don't see any questions. So I think at this point in time, I want to thank you all for attending. We will make this webinar available to view and listen to after the fact. We'll send you an email on that so that if you have other people in your organization who would like to avail themselves of the webinar, we can make sure that they have that available in the next couple of days. If you do have any questions, let us know. Happy to get back to you as soon as possible. Thanks, Rajan, for your presentation. I think everybody probably learned quite a bit today, and thank you all for coming. We appreciate it. Have a great rest of your week and enjoy your weekend.